Today, we're going to put on our detective hats and investigate, well, the biggest case of all, the universe itself. So, is it some kind of predictable clockwork machine with a grand solution, a theory of everything, just sitting there waiting for us to find it? Or is there something deeper, something fundamentally unknowable, baked right into its code?
Okay, let's really get into this question. I mean, if the universe is deterministic, that means every single event, from a star exploding billions of light years away to you hearing my voice right now, was all set in motion from the moment of the Big Bang. It's a nice, tidy, solvable puzzle. But what if the very tools we're using to solve it, mathematics and logic, what if they have their own built-in limits?
So our first clue, it comes from a really strange place, the numbers themselves. We tend to think of math as the language of cosmic certainty, right? But it turns out it's hiding a chaotic little secret.
Yeah, you probably remember this from school. We all start with the natural counting numbers, 1, 2, 3. Then we expand to integers to include negatives, then rationals, which are just fractions. Then you get the real numbers that fill in all the gaps, and finally, complex numbers. It all seems like a complete, perfectly orderly system, doesn't it?
Well, get ready for the twist. Those numbers on that neat little chart we just saw, they are a tiny and infinitesimally small fraction of all the numbers that actually exist. It turns out almost every single number is a kind of ghost that we can never, ever truly capture.
So most of these ghost numbers are what we call transcendental, like pi. Their digits just go on forever without ever repeating. But then it gets even weirder. The vast majority are non-computable, and that means there's no possible algorithm. No computer program we could ever write that can actually calculate their digits. They are fundamentally beyond our grasp.
And the ultimate example of this is a number called Chaitin's constant, or omega. Now, this is a specific, real number, but its digits are completely and utterly random. If you know one digit, it gives you absolutely zero clue what the next one's going to be. It's literally a number that's defined by pure chance.
This brings up a huge question. If the very language we use to describe the universe is just saturated with these unknowable random numbers, how could the universe itself be perfectly predictable? It really suggests that the uncertainty isn't just in our measurements, but maybe it's woven into the mathematical fabric of reality itself.
All right, so our second clue isn't about the nature of numbers themselves, but about the limits of what we can even do with them. And this one starts with a little personal story about a high school student way back in 1993.
So, he learned how to solve second-degree equations using the good old quadratic formula. And he started wondering, was there a similar, elegant formula for third-degree or cubic equations? He actually found a note in an old textbook saying one existed, and he became totally obsessed with finding it.
He just couldn't find it himself, so he asked a friend to go ask his math teacher for him. The student was expecting to get a formula back, or maybe a hint, some kind of guidance. But instead, he got a warning.
Don't get into that. Now, the teacher wasn't just being mean, he was trying to save this kid from a deep, dark mathematical rabbit hole. A problem that, while it is technically solvable for cubics, it hints at a much deeper, unbreakable wall in mathematics. And this was the wall the teacher was warning him about. A proof from way back in 1824, the Abel-Ruffini theorem, established that some problems are just unsolvable. There is no general formula using simple arithmetic and roots that can solve equations of the fifth degree or higher. And it's not that we haven't found it yet, it has been proven that one cannot exist, period.
Okay, so we've seen limits in numbers, we've seen limits in equations. Our final clue. This one takes us to the absolute foundation of all reasoning, logic itself. So every logical system, from geometry to physics, is built on a foundation of axioms. These are statements we just accept as true without proof, like, a thing is equal to itself. And from these simple little seeds, we build these enormous trees of knowledge. But then, in 1931, a logician named Kurt Gödel came along and dropped an absolute reality-shattering bombshell. His incompleteness theorems proved two staggering things about any logical system, and that includes mathematics. First, there will always be true statements that you can never prove within that system. And second, no system like that can ever prove its own consistency.
Just think about what that means for a second. If the universe operates on a consistent set of laws, which is just a logical system, then Gödel's theorems imply that it can never be fully understood from the inside. There will always be truths about the cosmos that are just beyond our ability to prove.
A complete theory of everything isn't just hard. It's logically impossible.
So, where does this leave us? We've got unknowable numbers, unsolvable problems, and unprovable truths. The case for a random, indeterministic universe seems pretty overwhelming. But if that's true, why does everything around us seem so predictable? Why do planets follow their orbits so perfectly?
Let's just recap the evidence one more time. Mathematics, the very tool we use to describe reality, is absolutely riddled with randomness. Some mathematical questions are provably unanswerable, and logic itself has these fundamental, built-in limits. It really seems like the deep-down reality of the cosmos is chaotic.
To understand how order comes out of all this chaos, just think about rolling 2 dice. Can you predict the outcome? Of course not. Even the most likely result, a 7, only has about a 17% chance of happening. It's way more likely you'll get something else. At this tiny scale, randomness is king.
But now, what happens if we scale that up? I mean, way up. Instead of 2 dice, imagine you're rolling 10 to the 80th power dice. That's a 1 with 80 zeros after it. A die for every single particle in the observable universe.
All of a sudden, something that feels like magic happens. With that many dice, the average result becomes incredibly, unbelievably predictable. The law of large numbers completely takes over. You could bet your life that the total sum would fall within this razor-thin margin of the expected average, and you would win every single time.
And this, right here, is the universe's big secret. Down at the quantum level, it's this crazy sea of probability and uncertainty. Billions upon billions of dice being rolled constantly. But at the macroscopic scale that we live in, all that randomness just averages out, and it creates the wonderfully reliable, seemingly deterministic laws of physics that govern everything from planets to people.
So it turns out the universe isn't some simple puzzle we're going to one day solve and put back in the box. It has fundamental, baked-in limits on what can be known and what can be predicted. But does that make it any less beautiful? Or does the fact that there will always be new truths to discover, new mysteries to explore, make it infinitely more magnificent?